In this video series, I'm going to measure to determine the power cylinder and the piston to determine if they are a match. Now, in this class, we'd make a selective assembly of these two parts. So, this part may appear to fit in this hole. It is certainly a tight fit. But is that fit too tight, or is it, is it tight enough? Is it too loose? Certainly appears to slide in there, but we will determine that using our measurements. So to measure the piston and the piston cylinder, we'll get the measuring tools from this drawer here. We'll need this need the Michitoyu there, and we'll need the bore gauge as well. Okay, so to measure the piston, we'll turn this on, and you notice it reads 0. Well, it obviously isn't 0 because this can pass right through and this has a certain diameter. So we will use the large handle. So this is the large handle, this is the small handle. Large handle, small handle. And we'll bring that together. Now I really don't want to use the large handle to bring this to the 0 point. Also make sure that these two surfaces are clean before you bring it in. If there's a piece of dirt in there, then you'll be measuring that piece of dirt and not these two pieces touching each other. Okay, so I'll bring them close with the large handle, and then I will bring them together with the small handle, and you'll hear it click. So this has a certain amount of torque, and then it just starts clicking. So you cannot damage the part or the measuring tool if you use the small handle. Now if you use the large handle, you can really reef on this thing and destroy the tool and your part, which we do not want to do. Now notice that it reads negative 0.0647. Well, that's not really what we want to do. We want it to measure 0, so we'll turn it on, or we'll turn it off, and then we'll turn it back on again, and now it reads 0. And if I move it back, and move it forward, it will go back to 0. Okay, so now I'm going to move it back. I'm going to move it back, and I'm going to measure the piston. I'm going to measure the piston in a couple different places. I'm going to measure it on this end, I'm going to measure it somewhere in the middle, and I'm going to measure it somewhere on this end here. So I'll measure the bottom. We'll call this the bottom. We'll call this the top. And we'll measure the bottom. And we'll rotate the part as we go through. And it's important to measure. You certainly can measure the diameter like that, but obviously I'm not measuring across the two points. I'm measuring some smaller diameter. So be careful that you're actually measuring across the diameter. Okay. So I measure 0.6235, and I'll rotate it a little bit. And I measure 0.6236, and I'll rotate it a little bit. And I measure 0.06236. So I'm concerned about the maximum dimension that I measure. So it appears the maximum dimension that I measure is 0.6237. So I'm going to take a pen and paper, and I'm going to write down 0.6237 inches. and you can see the readout right on the screen here. So there's 0.06237, and that is at the top. And I'm going to write mid and bottom as well. So I'm going to measure somewhere in the middle now. So 0.6235, 0.6234, 0.6236, 0.6235. So the max is 0.6236. Okay, fairly consistent. And then I'm going to make one more final dimension across the bottom here. .6235, 0.6236, 0.6236, 0.6236. So 0.6236. Now this is a very consistent piston. I have seen them all over the place from 0.6236 all the way to 0.6241 or something like that within the same piston. So a fairly large, relatively large fluctuation in the diameter. But this is a fairly consistent piston. So does this piston fit this power cylinder? Well, let's see. First I'm going to move this measuring tool out of the way. I'm going to use this bore gauge. Now this bore gauge doesn't go to 0 because, as I close this trigger right here, this end moves in and out. And obviously it's got a minimum diameter at the end of the tool, so it actually can't measure a 0 diameter hole, which when you think about it conceptually is impossible. You can't have a 0 diameter hole. So, but anyway, this tool right here goes to a minimum of, I believe, 0.5 inches to a maximum of 0.65. And you may be able to read that if it focuses properly on the end of the tool. Anyway, so we have a gauge here that is exactly 0.65001 inches. So this hole is exactly 0.65001 inches. So I'm going to stick the probe into this hole. I'm going to make sure that there's nothing in here. Now, this is obviously, if this was we wanted to get a really accurate reading, we'd be using a controlled air temperatures. We would be making sure that this is scratch free, using paper or lint-free wipes to clean things. But we're doing this in a shop environment, so forgive me if this is not to a metrology standard. So anyway, we'll put the probe into the hole. Well, first we have to turn the machine on. We have to press on. But I'm going to calibrate this machine to this diameter. So I put the probe in the hole like this, and I'm just going to rotate it to make sure that it's seated properly. And I read that it's 0.0650000. So that is the preset diameter. If I want to set it to the preset diameter, I press the preset button, and then I press it again until I get this play symbol here, and then it will start working. So I'll take that off, and when I depress it, the numbers change, and when it opens up, the numbers change as well. So I measured the piston in a couple of different places. I'm going to measure the power cylinder in a couple of different places. So I'll call this one with the non-flat end. This is the flat end right here. This is the top of the part that's not flat. I'm going to measure this one as the top. So I'm going to measure in 3 different places. I'll measure the top, the middle, and the bottom. So you stick the probe into the power cylinder and then rotate it. So just sort of rotate the part till you get the smallest reading. So the smallest reading I get is 0.62525. 0.62525. So I've just recorded that number, and then I'm going to put the probe somewhere in the middle of the piston, and I'm just going to rotate the part to find the smallest cylinder size. So again, the smallest size that I read is 0.62520. And then I'm going to measure the bottom. So I don't want the probe sticking out of the part. I'll get an inaccurate reading if I do that. So the probe has to be all the way within the part to get an accurate reading. So I'm going to just rotate it. And the smallest reading I get is 0.062520. So that is very, very, very good. So that is how you measure the piston cylinder and how you measure the piston.